Welcome back, folks. In today's class, I'll talk about the acceleration due to gravity. In the previous class, we were talking about the uh, formula for the force, that was force equal to gm1 m2 divided by r squared. That's the formula we learned about when there are two bodies involved. The body A has a mass m1 and the body B has a mass m2. What is the force of attraction between these two bodies? Now if there is one body and there is another body down here like a satellite which is at distance from the earth's surface, and we wanted to find out how much is the gravitational pull on this satellite. So example, this question. So in this question we are given that the satellite orbits earth at a distance of 3r earth from the earth's surface. Use the data and how many earth's radii the satellite is from the earth center. What is the magnitude of the gravitational acceleration of the satellite? So that's these are the two things which we wanted to find out, and this is the question I've taken from the Pearson book. On page number 218, this data is given to you. So let's dive into this question. Now it's given to us that the uh, distance of the satellite is from the Earth's surface. That is 3r. Now what is r? R is, you can call it as a radii of the Earth, or you can call it as the distance of the Earth center from the surface, which is 6.38 times 10 raised to the power 10 raised to power 6 meters. So the total distance will be equal to 4r, because this distance, if I zoom it in, this distance is r and this is 3r. So r plus 3r is equal to 4r distance. All right. If in the question it was given to you that the distance is from the Earth center, the satellite's distance from the Earth center is 4r, then that's about it. So in the question we need to always look into that whether the distance is given from the Earth's surface or the Earth's center. So if it is from the Earth's surface, you have to add another r to it to find out the gravitational pull, because we have to consider the center of the body, from the center of one body to the center of another body. Now you can also argue the question that why we haven't taken the center of the satellite, because satellite is a very small identity compared to the Earth. So the distance of the Earth's surface from its center is far more compared to the distance of the satellite center from the satellite surface. We can neglect that distance, but we cannot neglect the distance of the Earth center from its surface. Okay, now coming back to this question, what we wanted to do is we wanted to find out how many Earth's radii the satellite is from the Earth center. That's what we figured out. That is 4r. What is the magnitude of the gravitational acceleration of the satellite? So we wanted to find out what is the gravitational pull on this satellite which is acting. Okay, if you were on the surface or the satellite was on surface, it was 9.81. We've already learned that. Okay, and then now at this distance, how much is the gravitational pull? That's what we wanted to find out. So we will use the formula G equal to gm1 divided by r square. And which mass I'm going to use? Because we wanted to find it from the Earth's surface. So what let's read the question. How much is the magnitude of the gravitational acceleration of the satellite? Means how much is the pull which is being applied on the satellite. So we will consider the mass of the Earth. So that will be equal to G value 6.67 times 10 raised to the power 10 raised to power negative 11 multiplied by mass of the Earth, which is 5.97, which is 5.97 times 10 raised to the power 24 divided by r. The r will be equal to 4 times 10 raised to the power, not 4 times, it will be 4 times 6.6, 4 6.38, 4 times 6.38 times 10 raised to the power 6 close the bracket and square it. So again, once you're going to put this values in the calculator, you need to make sure you start with the bracket 6.67 times 10 raised to power negative 11 multiplied by 5.97 times 10 raised to power 24, close the bracket, divided by, start another bracket, 4 times 6.38 times 10 raised to the power 6, close the bracket and square it. That's how only you will be able to solve this question if you are one of those students who like to put everything into calculator at once. Okay, and then your final answer will come out to be 6.11 times 10 per negative 1 meter per second square. That will be the acceleration due to gravity, which is being acted on the satellite by the earth. Okay, that's how you're going to solve this question. So hopefully now you're clear about how to solve the force questions and the gravitational acceleration questions. And I'll see you with another video. Till then, goodbye.